Hey everyone, thank you so much for joining in. So, folks, can you please confirm whether you can hear my voice and see my screen as well? So, can you please confirm whether you can hear my voice and see my screen? I'm just sharing my screen on the social media platform. Okay, so please confirm now, folks, whether you can hear my voice and see my screen. Oh, thank you, Madan. Okay, I can see learners joining in from various platforms with us. And to understand and learn more about how to prepare for one of the important certificate, I would say, especially if you're someone who's into the field of DevOps and transitioning towards MLOps. So that is the Kubernetes Certified Administrator Certificate. Now, this session is important for the folks who are planning to take up this Kubernetes certified administrator examination, or a DevOps engineer who is working and who wants to upskill himself in the Kubernetes, or any data science practitioner who wants to upskill themselves in the Kubernetes. So, those are all the valid attendees for this session. Now, I'll do my best to keep it simple, to keep it general, so that you can get the most out of this webinar session. Now, as we progress in the learning journey, in case if you get any questions, feel free to let me know, because in this session, we'll have a mix of the approach, like we'll have a hands-on approach, and we'll also look into the theoretical concept, which are some of the core concepts of Kubernetes. Okay, the slides that I would be using as part of this today's session is already made available on the Manifold AI Learning page. Let me just bring up the page of Manifold AI Learning, where I can show you as how you can access the slide resources as well as the sessions recording. So once the session is completed, we'll be also uploading the sessions recording on the Manifold AI Learning platform. So you can access the sessions recording by visiting the page of manifoldailearning.in. Let me share the link over here in the chat window. So do check out the link over here in the chat window, which I'm sharing right now. So here, okay, let me share you the course link itself. This is the course link, which you can actually go ahead and access it. So using this course link, you can access the learning resources. That's nothing but the slides, as well as the code file, which we will be demonstrating it as part of our hands-on. And once the session is completed, we would also upload the sessions recording on this platform itself, so that you will be having the access for the sessions recording too. Okay, so yeah, so I have shared you the link. Now this session is made possible by the team of Manifold AI Learning. So Manifold AI Learning is a e-learning platform which has the goal to upskill the learners in the field of data science, machine learning operations, as well as the overall certification learning journey. Now my name is Nachiket, and I'm one of the instructor at this Manifold AI Learning, where I take the sessions related to the data science, machine learning, deep learning, as well as the topics related to the machine learning operations. Now, as I mentioned, as part of this today's session, I'll take you through the certification preparation journey that you need to follow, some key things that you need to remember. And also, if you're someone who is new to the Kubernetes, the topics that I'll be sharing you is very much important, because I'll take you through the basic level and help you understand what is this Kubernetes and what are the individual elements that you would have, the components that you have got in the Kubernetes, which makes it easier for you to learn more in the learning journey. Now, as I mentioned, this session is made possible by Manifold AI Learning. Manifold AI Learning has got various courses around this topic. Now, since you're someone who's from the Kubernetes like DevOps background, I would highly recommend you to learn the Python programming. So this is a new and the upcoming course on the Python programming for DevOps and the MLOps engineer. Because what we have seen in most of the project is, so we have got the DevOps engineer, but they lack the programming skill of Python. Now, Python is one of the most widely used programming language. We have tailored this course. The course curriculum has been tailored such that here you'll be learning the concepts of DevOps and the MLOps in the Python programming language. It's not just a general Python programming language, it's a Python programming language specifically for DevOps and MLOps engineer. Now remember, this is a early release course, which means the price that you see right here, it is only for the early joiners. The expected date where you can expect the first batch of videos to drop is 15th of April, and the overall course duration will be around more than 15 hours. That's the plan as of now, but it is about to change. But yeah, that's the overall idea. If I want to give you an overall things that you would be covering as part of this Python programming for DevOps and MLOps engineers is, like, you'll be gaining the solid grasp of Python basics, which in line with how you would use it in DevOps and the MLOps task, how you can automate the workflows with Python script, how to manage the infrastructure in an effective manner using Python programming language. And you'll also see how you can deploy and scale the machine learning models and some of the best practices that you need to follow when you are writing the code in Python programming language. Now, as you can clearly see, this is a course. It's not just a simple course, it's a course which is tailored for the DevOps and the MLOps professional. I highly recommend you to check out the same so that you can use it in your learning journey. And this is a best price that you see right now, and as and when the new videos will be added, you get to have the access. And now, apart from that, if you're someone who's into the MLOps, you can also check out these courses as well, which would help you to dive deeper in this topic of MLOps. All right, guys. So this was about the manifold AI learning and what we do at manifold AI learning. As I mentioned, I'm one of the instructor, and I've got the opportunity to create the courses for all their retail offerings. You can check out their site. And since you have joined with us on this webinar session, so there is a special coupon code which has been enabled for the webinar attendees. So currently there's an offer that's running, that's holy. So you can apply 15%, you can apply this coupon code and avail 15% off. Now, on the non-sale days, you can also check out the coupon code of webinar 10. Using this webinar 10, you can avail 10% off on the prices that you see on the website that is of this Manifold AI Learning. Okay, now let's come back to our topic, which is about Certified Kubernetes Administrator Certificate. Now, the best place to learn and prepare for any certificate examination is by visiting the official certificate page. If I take you to the official certification page of Certified Kubernetes Administrator, so you can get the latest update about the things that you need to remember. So first thing is, the examination cost is $395, and this is for examination only. There's no sessions or anything planned that you would get. It's an examination cost only. Okay, and apart from that, few more things that you need to remember is, so here the main idea of this Certified Kubernetes Administrator program is to give you an assurance that these Kubernetes, the certified Kubernetes administrators have the necessary skill, knowledge, and the required competency to perform some of the complex tasks, and they are able to take the necessary and the responsible role of the administrators. That is the Kubernetes administrator. Now, here you'll also get an exam simulator as well, which will be provided, and this is a latest announcement that has been made. Okay, this is a latest announcement that has been made by the CKA team, where they have mentioned that effective April 1, 2024, the certifications that you will be achieving it, okay, will be expiring it in 24 months. So that's something that you need to remember. Okay, so here As part of your learning journey, this certification is for Kubernetes administrator. Now, if you're someone who is preparing for this examination, some of the core competencies that you have to focus on are these. The storage has got 10% of weightage. For troubleshooting, you've got 30% of weightage. Workloads and scheduling, it's 15%. Cluster architecture, installation, and configuration of the Kubernetes cluster, it's 25%. Services and networking, it's 20%. So you can clearly look into this, that they have carefully designed and provided the weightage as per the Kubernetes administrator role. So most of the time, as a Kubernetes administrator, you would be troubleshooting the various issues. Let's say some upgrade has happened and your pod is not starting, or the pod is behaving in a weird manner, and you end up there. There can be a scenario where the pods are getting scheduled on a specific node which you do not expect. Or to give you an example of the MLOps, where you want the pods to be scheduled, which is powered by GPU, but the worker nodes that it has selected, it is a general purpose CPU workload. So those are all the places where we see the expertise, where in the project we see we seek the expertise from the Kubernetes administrator. So having those knowledge would come in handy for you, because you'll be able to solve the multiple production problems that you would come across, and you'll be able to solve it in an effective manner. So that's how you'll have to focus on. Now, if I just expand it, when it comes to storage, you need to have the understanding about the storage classes, the persistent volume. You'll have to understand the volume mode, access mode. You'll have to know about the reclaim policies for the volume. You'll have to understand the persistent volume claim primitives. How does this overall concept would work? And you'll also have to know as how to configure the application with persistent storage. Under the troubleshooting, you should be familiar and comfortable in evaluating the clusters and the nodes, and you'll also be able to check the logs as and when it is required, understand how to monitor the overall application, and you should be able to manage the container standard output and the standard error logs, and you should be able to troubleshoot the application failure, which is one of the use case that I've described earlier. The other things is troubleshooting the cluster component failure and troubleshooting the networking as well. Coming to the workloads and scheduling, you should be comfortable in understanding the deployments and how to perform the rolling update and rollback. So rolling update is a case where you want to update the application in a manner, in a sequential way, where you will delete the existing pod and you will create the new pod. And rollback is bringing back with the old version of my application. You should be comfortable in performing the rolling update and the rollback. You should be comfortable in using the config map and secrets in order to configure the application. So obviously, it's not recommended to store the passwords and everything as a text file format. No one recommends that, and it's not a way in which you would implement it in the production environment. So you should be familiar with the secrets and the config map, which you can load it as the environment variables or as a volume, which would help you to use it in the pod, which you can consume it inside the pod and bring up the application and ensure that your application is working as per your expectation. And you should be familiar with scaling the application, and you should be comfortable in understanding, and you should be comfortable in the topics like self-healing, application deployment, and you should be comfortable in implementing such that your application and the pod that you will have, it will have the self-healing properties. And you can also make use of the topics like node affinity, and you can mention such you can use those concepts and ensure that the pods will be scheduled on the required worker node. And other tools that you should be aware of, the manifest management and the common templating tools, which would come in handy. Now coming to the next module, that is cluster architecture, installation and configuration. Here you should be comfortable in working and managing the RBAC, that is role based access system. So you should be comfortable in using the kubeadm to install a basic cluster. You should be comfortable with that command, the basic command to work with the Kubernetes cluster itself. And you should be aware of managing the highly available Kubernetes cluster and provision the underlying infrastructure to deploy a Kubernetes cluster. Perform the version upgrade on a Kubernetes cluster using the kubeadm command and implement the etcd backup and restore. This is one of the common activity that you would be doing it as an administrator, that is taking the backup of the etcd and restoring the backup. So because you know that etcd is like a memory for our Kubernetes cluster, and if that is lost, so we will be losing the states of the pods and the application that is currently running. So it is very important that you know those techniques as well as how you can implement such HCD backup and restoring it. And obviously to enable the communication between pod to pod and the node to pod and the connectivity between the pods and connecting our application to the external system. So these are all the various concepts that you need to be aware of. Like you should be aware of the host networking, you should be aware of the networking configuration, you should be aware of understanding the communication and the connectivity between the pods, and you should be aware of the various basic network components like what is network, what is this cluster IP, node IP, load balancer service type, and how does this endpoint would look like. And we should be comfortable in using the ingress controller and the ingress resources and work with the various CNI plugin, that is container network interface plugin. So these are all the core expectation of the certificate examination. I highly recommend you to check out this official page. I'll share the link over here in the chat window right now. So go ahead and refer to this official page to get to know more about the recommendations for preparation for this Kubernetes Certified Administrator certification. And there's also a candidate handbook that has been shared to us. You can actually click on it, and this would redirect you to the GitHub repository. Now, once you are there in the GitHub repository, okay, this would actually direct you to this page where you can get the handbook, like where they will talk about how you can give the examination, and this is a proctored examination. They have explained everything in detail over here in this page. You can get the overview of the curriculum by clicking on the hyperlink, and this would take you to the GitHub repository where you can access the curriculum. So that's the basic that you need to remember when you're preparing for your Kubernetes certified administrator examination. Okay, so that's something that you need to remember. Now that you are aware of the basics of the examination preparation, now let's go ahead and let's understand how to create pods inside this Kubernetes cluster. But before that, let's look into the various components of a Kubernetes cluster. So before I deep dive into those topic, guys, I've got a question for you. So, what is your comfort level in the Kubernetes? Are you aware of the Kubernetes cluster and working with the same, or is it new to you? So, can you please let me know over here in the chat window? How comfortable are you in working with this Kubernetes cluster? And even working with Kubernetes in general, how comfortable are you folks? Okay, I see some responses already. So Rakshit says, I'm very new. Dheeraj says, I'm pretty new. Okay, how about others? Okay, I can see most of the responses that I see here are like the learners are relatively new to this topic of Kubernetes. Okay, over here. So Josie has got an intermediate level, and Padmanabhan has some idea on Kubernetes. Okay, that's great, guys. That means in our live session today, we've got the learners from various levels. We've got the learners who are beginners, and we also have the learners who are at the intermediate level as well. So we'll start with the basic, and I'll take you through some of the hands-on. The agenda of the session is to give you some background about this Kubernetes, as well as the idea about creation of pod. Okay, so that's what we'd be doing, guys, and I'll also share you one example application as well, if in case if you're someone who wants to just refer to it for an example. Okay, so let me just bring up the example that I've got. Okay, so first let's proceed ahead with our learning journey of learning the basics of this Kubernetes. Okay, let's go ahead and do that. So here, let's understand what exactly is this Kubernetes. So Kubernetes is like an application orchestrator. And for most of the part, what this Kubernetes is going to do is it's going to orchestrate the containerized cloud native microservice application. Well, there are a lot of terminologies that I'm using it right now in the definition, but don't worry, I'll break it down these components so that you can understand it. So first, let us understand what exactly is this orchestrator. Now, an orchestrator is basically a system that would deploy and manage the application. And that's what an orchestrator is. Like, for example, it can deploy the applications, it can dynamically respond to the changes in my application. So, like, for example, if I take up the Kubernetes itself, which is an orchestrator, so what it can do is it can deploy our application, it can scale up and scale down depending on the requirement. We have the capability over here. It can self heal when things break. And the best part is this Kubernetes can perform zero downtime rolling updates and the rollback. And lots more benefits that we would get when we talk about any orchestrator. So when I say Kubernetes is an application orchestrator, you have now understood about the term that is orchestrator. Now, what is containerized application? Containerized application is an application that run inside a container. So we'll create the image. So basically we'll make use of the container runtime. There are various container runtime that we have got, and one most widely used container runtime is Docker. So you would make use of the Docker. Okay, you would make use of the Docker as your runtime. Okay, and using that like using the Docker, which is your container runtime, you would go ahead and create your containerized application. Okay, you'll create your containerized application, and that application will run inside a container. So when you're building a Docker image, so it will have the Docker image, and this Docker image will have the application code, it will have all the dependencies, so that it can run. Okay, so that it can run in an independent manner. So that's the basic idea about this containerized application. And when I say cloud native app, so when I make use of the term cloud native, people will think that that's an application that runs only on the cloud. But that's not the case. When I say cloud native application, it's an application which is designed to meet the cloud like demands, like the auto scaling, self healing, rolling update, rollback. So if I have built an application, okay, if I've built an application which which is like if I build an application, if it caters to these requirements of the cloud, then we call that application as a cloud native application. Okay, so cloud native is nothing but it's a way in which the applications behave and the way in which the applications react to the events. Okay, now I've also made use of the term called microservice application. Now let us define what is this microservice application. Now when I say microservice application is built from various components, like it is built from various small components which are specialized. Okay, they are specialized and they are created to do a small task, small meaningful task. So that's what a microservice application is. Okay, and like for example, if you take up an e-commerce application, it consists of various small specialized independent components. Like it will have a web front end, it will have a catalog service, shopping cart, authentication service, persistent store, as well as the logging service. So that's what an microservice application will be made up of. Okay, and here when we talk about such microservices, so each of the features is developed and deployed as its own small application. Okay, so each of the application that we would be building it, so it will be developed and deployed as its own small application or the small service, and we can use them as the microservice. And one thing that you need to remember is each of these components that I'm saying, it will be built by the respective individual teams. It's not a single person or a single team building it. So each component will have its own release cycle, and each component has to be scaled independently. Now think about the complexity that you would have whenever you are building such application. So you'll have multiple components in a very big application, and each and every component is built by an independent team, and it has its own release cycle, it has its own dependency. So when we talk about managing such complexities, that's where the orchestrator like Kubernetes would come into picture, and it will be of highly useful for us. Now, now that we have understood about the various component breakdown about this Kubernetes, if I now want to describe this Kubernetes, Kubernetes is an application orchestrator. So it manages and deploys the application which is packaged to run, which is packaged, and it will run as the container. Okay, that's the overall idea about this Kubernetes. So now that you have the basic idea about this Kubernetes, so let's proceed ahead, and let's, like for the interest of time and for the one that is related to us, we'll understand. Okay, let me just bring up the file that I have got. So instead of me skipping here, I'll just bring up the presentation that I have specifically created. So we have learned about the orchestrator, and we have learned about what is a cloud native application and its importance. So now that you have learned about it, now you might be wondering as why is it Kubernetes is so much important for us? Well, think about it. So when you think about sending the package to someone, now in such scenarios, what you will generally do, you would, as a person who is sending the package, you would go ahead and prepare the package. You will add a label on top of it, and then you'll provide that package to the courier person or the courier people or the courier company. Then this courier company is the one that would manage everything like manpower, routes, tracking, schedule changes, delivery of package to your loved one. So everything will be managed by that courier company. Now Kubernetes does the same thing for you. So that means as a developer, you would build an application, you will package it with the help of Docker images and the overall Docker package. Like you can build it as a Docker image and package it. Once you package your application, you will just provide it to the Kubernetes. Now the Kubernetes is going to look through the Kubernetes manifest that I would provide, and then the Kubernetes will take care of everything in the backend. Like it will take care of the deployment, it will take care of self-healing, it will take care of a rolling update, whatever the activity that I would specify, it will be taken care by the Kubernetes only. And that's the importance of Kubernetes when we talk about the deployment. And this doesn't just is limited to the software engineering, even in the machine learning aspects as well. So we see the importance of Kubernetes. Like when we want to deploy the machine learning based application, I want to deploy it on a pod which has got the ability of horizontal pod autoscaler, and I want to place a node affinity to my pod where the nodes are part of the GPU clusters, where it can learn the where it can run on the complex where it can run the complex deep learning algorithms. So that's the reason that it is very important that you understand and work with this Kubernetes. So now that you have understood about this Kubernetes, okay, let's go ahead and understand about the architecture of this Kubernetes. So let's see how does the architecture of this Kubernetes would look like. That would give you a picture about what is this Kubernetes and how everything would work together. When we talk about Kubernetes at a very high level, so as I mentioned, it's a cloud native microservices application orchestrator, and it's a cluster where my applications would run on. Now, when I say cluster, okay, when I say cluster, so cluster is basically the group of machines which we will be using it to host the application. It's a group of machines. It's a group of machines which will be using it to host our applications. And each machine which I have part of my cluster, we are going to call it as the node. So the node are the individual component. Okay, the node are the individual machines that runs on my cluster. And these nodes, okay, this is an important part. Okay, the nodes that I'm speaking right now, it can be anything. Now these nodes can be physical server which is in my on-premise environment, or these nodes can be virtual machine, it can be cloud instances, it can be Raspberry Pi, and it can be anything. So which means what we are trying to say is Kubernetes cluster is a group of machines, and each machine we call it as a node, and these machines can run anywhere irrespective of the infrastructure. So it can be the virtual machine, it can be servers, cloud instances, and it can be anything. So think of it in this way. Suppose you have your MS Word application. Okay, you have the MS Word application, and let's suppose that this Microsoft Word application you have installed on Windows 10. So on this Windows 10 operating system, you have installed your application. So that is what you have done right here. Okay, so now that you have installed this application on the Windows 10, so you can run this application. Now, this when you are installing on the Windows 10, when you're using this application, you don't care what kind of system that I are running. Like you don't care about the technical details as what is the CPU usage, what is the hard disk usage, how much memory that I'm consuming, and what things are connected. You don't care about it, isn't it? As an end user, you'll just be worried about your application running perfectly and you are able to access it. Now, with this definition of node, what we can conclude is we can say that a Kubernetes is like the OS on cloud. It's an OS on cloud. Let it means that suppose you've got an application, okay, and you decide to run it on the Kubernetes cluster, you'll just provide it over here to your Kubernetes, and this Kubernetes will manage everything. It can work on the physical machine, it can work on the virtual machines, it can work on the cloud instances, or it can be Raspberry Pi. So it can be anything. So in one sense, it is acting like the operating system on the cloud. Now that's the benefit, and that's the reason why people and the companies starts using this Kubernetes for their production environment. It gives us so much flexibility for us, and the best part is since the infrastructure is separate, so the companies are no longer bound to a single vendor. So they are no longer bound to a single vendor. They can make use of any vendor of their choice and they can start using it. Suppose if this is my Kubernetes cluster and this is my virtual machine on AWS, now I would decide that I don't want AWS. Maybe I want to replace it with GCP. We can directly switch it because from our perspective, the Kubernetes will, it is just like a change in infrastructure, and whatever the application that we have built for Kubernetes, it's not specific to that particular operating system, or in this case, particular infrastructure provider. So that's the benefit of this Kubernetes cluster. Now, when we talk about the architecture, this is how the architecture of this Kubernetes would look like. Now, this Kubernetes has got various components. We've got the Kube API server, we've got HCD, we've got scheduler, we've got controller manager. Okay, we have got cloud controller manager. So these are the components of the control plane, which means, as you can clearly see in the diagram, so when we talk about the architecture of this Kubernetes, a Kubernetes cluster basically contains a control plane and the worker node. The node 1 and the node 2 see right here, we call it as the worker node. Okay, so this control plane is the one, is one of the, you can think of it as a kind of a brain of this Kubernetes cluster. Now, this control plane consists of various components. Like as I mentioned, it has got the scheduler. Now, using this scheduler, so sorry, we have got the API server. Now, using this API server, all the communication can happen. That means even as an end user, if I want to interact with my Kubernetes cluster, we'll be making use of this API server. And we have the scheduler, which is part of the control plane, and the scheduler is there for us to assign the work to the worker nodes. And control plane is the one that is responsible for keeping the applications healthy, and it is responsible for healing, auto scaling, rollouts, and many other things. And when we say worker nodes, what it does is it executes the user application. So it basically executes the user application, whatever the user application that we have got, it executes the user application over here and keep the control plane informed about the overall status. It will not take any decision. It will just keep the control plane informed about its overall status. And to do the communication, obviously, it will again make use of this API server. Okay, so when we talk about this worker node, this is where your applications would run. So this worker node, it watches the API server for any new work assignment, and then it will execute the work assignment. And based on that, it will report the status back to the control plane. Now, inside this worker node, it will contain the various components like kubelet, kube proxy, and container runtime. So these are the various components of the worker node. So when you set up a Kubernetes cluster, you will have the control plane. Some people will also call it as the master node, and you'll also have the worker node. Master node, where you can think of it as a brain of a Kubernetes cluster, which manages everything, and worker node is where our user applications would run. That's the overall idea about the components of this Kubernetes cluster. Now here we have mentioned that we want to first package our application, and then once we package our application, we will go ahead and provide this package to the Kubernetes cluster. Now what we do is, to be able to run inside the Kubernetes, whatever the application package that I'll have, let's assume this is my app and dependencies, which is described right here, we will wrap it under a high level object that we call it as the pod. So we will create a wrapper. Pod is basically a wrapper around our like our container image, to simply put, which has got the application and dependencies. And using this pod, we will go ahead and schedule the pod in the Kubernetes cluster so that we can get the applications running. That's the role of pod right here. And what we do is, like this pod, if I just go ahead and deploy the pod inside my Kubernetes cluster, I'll not be able to get the benefit like healing, rolling update, and all those things. So to get the other benefits, what we do is we wrap this pod inside the other Kubernetes, high level Kubernetes objects like the deployment or like the horizontal pod autoscaler. So like that, we will wrap this pod inside such high level objects of Kubernetes so that we can enjoy the benefits like scaling, updates, and the self healing abilities. Okay, that's the overall idea about packaging our application to run inside the Kubernetes. Now let's go ahead and let's get a feel as how we can actually work inside this Kubernetes cluster and how to perform in an hands-on manner. So I'll take you through a basic one so that everyone can follow along. So, and then I'll share you some resources as well, which you can refer it at a later point. Okay, so for the demonstration purpose, let me just go ahead and bring up a new notebook. So what I'll do is I'll create a new folder for today's activity. So there's already a one repository I believe that I had created earlier, which is called as Kubernetes 101 hands-on. We'll make use of the same. Okay. So here, if we want to get started inside this Kubernetes, so the first thing that we will do is we would go ahead and as an end user, we will create the YAML manifest file. Now this YAML manifest file is nothing but it's a file which is in YAML format, which contains the instruction which my Kubernetes should follow. Okay, it contains the instruction which my Kubernetes should follow whenever a certain activity is being performed. Okay, that's what the YAML manifest is. So you can have a file which has got the YAML or YML. Okay, now here the first thing that I have shown earlier was I have mentioned that whenever we want to deploy any application inside a Kubernetes cluster, we will wrap our application, which is our container image that we have got, inside the object called pod. And these pods are the atomic units of scheduling inside a Kubernetes cluster. So this file that you see right here, that is pod.yaml file, this is a file where it contains the information about how to create a pod. If you start with it over here, it says API version. It describes what is the version of this API. So whenever you are creating any YAML file for the Kubernetes cluster, you will have to specify the API version. Okay, now apart from this version, we'll have to specify the kind. That means what is the type of object that we are trying to create. Here in this case, the kind is pod. Now, apart from kind, there's another important one that you need to specify inside this YAML file, that is the name. So you have to add a metadata of name. And for this metadata of name, you can actually specify, okay, you can actually specify the name that you want to give for your pod. Here in this case, the name that is mentioned right here is called as first pod. Now, apart from that, I can go ahead and mention other details. Like these are all the additional details that I've mentioned, which I have mentioned it under the labels. So the labels consisting of the key pair values. It consists of a key pair value, which we would be using it, and we can refer to it at a later point. Whenever we want to link a particular service to the pod, we refer to these labels as well. Now, this describes about my pod object. Now, under the specification of this pod, there's a section called container. Now, here I have mentioned the details about the container that I want to use. So here, my container name is example container. The image is Nachiket Murthy / cat gif v1. That's the application image that I want to pull from the Docker Hub registry. And the container port that I want to open is 500. So this is how my pod.yaml file would look like. Okay, now let's go ahead and let's create a pod, guys. So in order to create a pod and work with it in a hands-on manner, first thing is we need to install the kubectl in our local system. Now, in case if you have got the Docker, so the easiest way to access the Kubernetes cluster is by enabling the Kubernetes inside the Docker itself. So that would actually provide you with the single cluster Kubernetes. So that is more than enough for you for your practice. Now, apart from that, you can go ahead and make use of the other resources. It could be the AWS or GCP or Akamai or any other cloud vendor. If you want, you can go ahead and create your cloud resources over there. That is your Kubernetes cluster over there. So for the demonstration purpose, I'll make use of my local Kubernetes cluster. So I'll go to the settings. And if you want to enable the Kubernetes under the Docker settings, you'll have to enable the Kubernetes by selecting this checkbox. So once that is done, you'll have to apply and restart, and post that you'll be able to access your Kubernetes cluster. See, once the Kubernetes cluster has been created, I mean, at least you have the access to the Kubernetes cluster. So the way that we would interact with our Kubernetes cluster is with the help of the command line interface that's called as kubectl. So let me just go ahead and share you some of the commonly used commands that we would be using it in the kubectl, so that you get a better understanding of the same. So we have got the kubectl, that's the command. And if I say get pods, it's going to generate the list of pods. If I say get pods hyphen o wide, it's going to generate the detailed list of all the pods that I have got. And like this, we have got various commands with us. Now, if I want to create a resource from my YAML file, I can say kubectl create hyphen f, mention the file name, or I can directly make use of another function, another command that's called as apply, and I can create a new resource using this apply command too. Okay, so I've already mentioned it in the GitHub repository. I'll be sharing it with you at a later point, folks. So that's the basic commands that you can access it. So here, let's go ahead and test out as well. First thing that I would do is I'll go back to the folder where we are currently in. So currently I'm inside the folder that is Kubernetes 101 hands-on. Now to test whether the Kubernetes is present or not, first you'll check kubectl. Just check as kubectl hyphen hyphen version. So you should be, so kubectl, just type kubectl guys. You should be able to display a message like this, which basically displays the help message for us. Okay, this confirms that there is like the kubectl is installed and we are able to access it, which means we do not have any problems in running the command. Okay, now that we have validated that we have the kubectl, that is the command line interface to interact with the Kubernetes cluster, to get the to check whether the cluster is up or not, I can check the nodes. What is the status of the node? I can say kubectl get nodes. So this will return to me as what is the status of the node. Here, the name of my Kubernetes cluster node is Docker Desktop, and the role is a control plane. Okay, it's a control plane. As I mentioned, since it's a local installation, I've got only one node which is acting like uh, like a control plane for us, and anything that I try to deploy, it will be deployed in the same control plane as well. But that's not the same case in the production environment. Just for the demonstration, I'm making use of this I'm making use of this method, guys. Okay, I'm just making use of this local resources so that we can get started. Now, once we have validated that our Kubernetes cluster is running, let's go ahead and create the pod. So I'll say kubectl apply hyphen f pod.yaml file. Now this has created the pod. It says pod slash first pod has been created. Now we can check the status of the pod by running the command as kubectl get pods. So this will tell me what are the pods that are actually running. In my case, there are other pods that are running. You can actually ignore it. So there are some pods from ChatGPT which I had built earlier. And the important thing for us is the first pod. Okay, this is the pod that is actually running, and you can check the age. It is 10 seconds. So it has been created just now. So in this way, we can create the pod. So pod is basically a wrapper for our application. Now, the question is, how can I check my application? How do I see whether my application is running successfully or not? Now, that's a question that we have got, right? So, how can we go ahead and check the status of my application? I mean, at least I want to visit this application. So, in order to reach the pod, okay, so what we make use is inside this Kubernetes, we make use of another object inside this Kubernetes that's called as a Kubernetes service. Now, one thing that you need to remember when we are working inside this Kubernetes is, so here when we are working with this Kubernetes, the pods are unreliable. So the pods are unreliable, which means if something happens, a new pod will get created. So you cannot make a connection specific to the pod. And let's suppose you update the version of your application. Okay. So in such scenarios, a new pod will be created and your old pod will be deleted. Now, in such scenarios, you cannot have a access to your application based on the pod. So it is not recommended as well. So that is the reason we make use of the Kubernetes object, that is the services. So what it does, this is this Kubernetes services. So it provides the reliable networking for the set of pod. So it provides the reliable networking for the set of pod. So what it means when we say reliable networking, so it means that, so even when my pod goes down and brings up a new pod, I would still be able to create or reach my application. So that means we will use the service as a front end. And this service will have the front end and it will consist of a DNS name and it will also have the IP address and port. So as a result of this, we get to enjoy the stable networking for the pods. For the dynamic set of pod, we'll be able to enjoy the stable networking. So that means if I have an application, let's suppose this is my pod and it is running the application A. So as an end user, to reach my application A, what I'll do is I'll make a call to my Kubernetes service object. Now this Kubernetes service object will in turn redirect my request to the pod that I'm trying to reach. That means the pod is nothing but the application where the pod is running. If I have multiple pods that are running the same application, so this acts some kind of a load balancer for us, which redirects the application to the required pod. Okay, that's the overall idea and the importance of this Kubernetes service object. So let's come back to our file. Okay, there's also a YAML file which is called as a svc cloud.yaml file. So this is basically going to deploy it on the cloud. Let me do one thing. Let me just first show you in the local system and then I'll take you through the other way, guys. Okay, so I'll just create a new file. I'll say svc local. Okay, we'll create a local where the local hosting will be on the node port. Now this time what I will do is I would go ahead and mention in this manner. Just a few things, team. I'm just validating few things. Give me a second. So what I'm trying to do is I'm taking the help of my previous implementation, which I did earlier for the chatbot. I'm just making use of the same. It's in the same GitHub account. So what I'm trying to search is the service which is going to deploy it on the node port. Okay, so this is what I was searching for. I'll just copy this port section and I'll be pasting it over here. Okay, now observe what is happening. So I have mentioned that here to be able to reach the pod. Okay, so first my target port, that container pod, the container port is 5000. The reason 5000 because if you look into the specification of the image, I have mentioned that the application is accessible in the container port of 5000. And that's the reason I'll mention my target port as 5000. That's the port that I want to reach. Okay, that's the port that I want to reach. Now, once I want to reach that port, here we'll also have to specify what is the node port. Node port is nothing but what is the local host port that I need to access. Okay, what is the local host port that I need to access so that I can reach this application which is running inside the container. And when I make this call to the node port, so which indirectly call the port of the service IP. So here I mentioned as 5000. Maybe if it gives you the confusion, maybe you can say 5001 or you can keep it as 5000. So you can modify the service port. So this node port will be connected to a service port, and this service port will redirect the traffic to the container port of 5000. Okay, so that is what we would specify. And coming to the type here, this type, the type is the node port. So it is not a load balancer. Load balancer is what we would use it when we are trying to deploy it on the cloud environment. For the name, I'll mention as local SVC. So if you look into this here, I've created the service object. So API version is v1, kind is service, the name is local SVC, and this is a node port spec. There is a specification. The port is 5000, target port is 5000, node port is 30002. So this is how I have specified inside this service configuration. Now let us go ahead and like test out whether it's working as per our expectation or not. So I would go ahead and say kubectl apply -f, and here we'll specify our svc local.yaml file. Okay, so it says that my port is already allocated, so this is because of my existing application. Let me just change the port to 30003. So this is because I think there's already an existing application that is running. Okay, so I think that could be a reason, since we have seen that, yeah, there is an application that's running. That's fine. So let me just use a different service port. So now the service has been created. So I'll say kubectl get svc. Get svc is what would help us to return the service object. Here we can see the output that says as 30002. That means the application is accessible from the port of 30002. So now we can check localhost 30002. Oh wait, I think it's 30003. I'm sorry guys, it's 30003. That's what we have configured. Okay, I think it's taking a time to load. Let's wait. In the meantime, let's get the information for pod. Okay, the pod is actually running. So let's check few things, and this is a good activity for performing uh, like it's a good activity of performing the thing, especially what we call it as a troubleshooting. So I've created the service object. Okay, and here I've just created the service object. But the problem, if you look at it in the service object, which I've just created, I have not specified how I should link this service to my pod that I'm actually running, which means here in this case, okay, I've not created the linkage. The way we create the linkage while working inside the service object is we create it by specifying the selector. Okay, I think I had missed it. Okay, let me just go ahead and mention the selector as well. So let's take, okay, there was a selector here. Let me just use the same. Okay, there was a selector that was missing. So I had to mention how do I provide this service? I mean, to which pod that I need to connect to. So now I mentioned as project CAD GIF. So it will look for the label of project and it will have the name as CAD GIF. So since the pod that we have created earlier has got the project CAD GIF, now if I go ahead and apply the service again, the service has been configured. Now let's go ahead and check. If I go to the localhost port of 30003, see, we are now able to go ahead and launch our application and we are able to reach our pod. And we were able to reach it with the help of the node port of 30,003, which in turn is connected to the service port of 3,000, 5,000, and that 5,000 is connected to 5,000 port of the container. So that's how the ports are actually connected and we are able to access the pods. Okay, so that's the overall idea of working with the pod as well as working with the services. Now let me update the GitHub repository so that you can get the information as well. So the link for the GitHub repository is the one that I'm sharing you right now on the chat window. Please go ahead and access the link. So this is where you can get the source code. Okay, I've shared you the link over here in the chat window, guys. So please go ahead and refer to it. Now, guys, while you're going through it, so please let me know, is the pace is okay? Are you able to follow along with me? So if yes, please confirm by typing as all good, or if you have got any questions on the topics that we have discussed till now, so please feel free to let me know. Or even if you have got any questions about the Kubernetes, MLOps in general, I'll be happy to answer any of the queries that you might have, folks. Okay, thank you, Darshan. Okay, so Pawan says, can you please explain about init container? Sure. So I'll explain at a very high level. So when we talk about the init container, so init container are the kind of a special kind of a container. Here, what we do is we make use of this init container where we can specify like where we can specify a certain logic. For example, whenever we have got an application, okay, whenever we have got an application, so wherever we have got an application where one pod has to perform the initialization first, followed by the instantiation of the other pod. That's when we'll be making use of this init pod or the init container. So if I take you to the init pod example, I think there's one example right here. So what I'm doing right now is here, this is an example pod that is present. Okay, so under the specification, there is first container over here, which is Nginx container, and we have mentioned the container port is 80, and there is a volume that I have mounted. Now there is an init container. So there is, which means what I'm trying to do is I'm trying to bring up a new pod. This is a pod, which I'm going to call it as the init pod. So what this init pod is going to do is it is going to create file. It is going to create file and store it in a certain location as a volume. So this will perform the initialization. Then once the initialization has been done, once the file has been mounted on the volume, so next thing, okay, next what I will do is I'll use the contents of the module of this volume that I've got. I'll mount it on the other pod, which can be my application pod, where I will refer to the contents of this volume and I will bring up my application. In this case, I'm reading the contents from this from this volume, which is basically my HTML file, and I'm using that HTML file inside this Nginx container. So that's a that's a very high level idea about how to work with this init pods. Okay, thank you, Pawan. Okay, any other questions, team? Okay, Vincent says I'm new to MLOps or DevOps. Any idea to where to start? Okay, so Vincent, that's good to know. So what you can do is, I think you had also registered for the previous webinar. So you can follow along with us on the live webinar series that we are conducting. So we are planning to present every week. Since you are part of the Manifold AI Learning community, you get the uh, updates, like you get the updates about the next session that is happening. And if you're serious and want to get started early, maybe you can also check out our premium offering from Manifold AI Learning website, where you can check out the course on MLOps Bootcamp. So one of the prerequisite is like you should be having some fair idea about the Python, but don't worry, the required Python is mentioned right here. If you're someone who is new to the Python, so I would recommend that you follow this course in a sequential way so that you can get the most in your learning journey. So this is how you can get started with MLOps journey. And apart from that, the alternative that I mentioned, I would highly recommend you to join our webinar sessions that we'll be conducting in a weekly manner. And once the webinar is completed, we'll be sharing the recordings to the learner and you can access it over there as well. Okay. Vincent, you'll be getting the recording videos once the webinar is completed. Within 24 hours, you will be getting the recorded videos of the webinar. Okay, and another question is which certification is better, CK or CKAD? That's a tricky question, Pawan, and everyone has its own uh, has its own I'll say a preference. So if I talk about CK in general, the overall target audience or the person who is suitable for the CKAs, that is administrator certificate, is like system administrator or a DevOps engineer, or if someone is working as a platform engineer who is basically responsible for designing, deploying, and maintenance of the Kubernetes cluster, where they work closely with the Kubernetes cluster. That's when the CKA would be an apt choice, because the CKA certification is going to test you upon the skill sets which are related to the cluster architecture, the installation, configuration, networking, security, troubleshooting, which you have seen in the domains at the start of the session. Okay, so if you want to be on the infrastructure side, so CK is a good one. Now, if you're someone who is an application developer or a software engineer who is basically into building, testing, and deploying the applications on the Kubernetes cluster, then Kubernetes application developer will be a suitable for you, because you will be those examination will be focused specifically on the topics like deploying the application, configuring the pod, containers, how to configure the storage, troubleshooting the applications with Kubernetes. So those are the ones those are the activities, or those are the skill sets that you will be measured upon in the Kubernetes application developer certificate. Okay, thank you, Pawan. Okay, any other questions, team? What about others? Are you able to follow along, folks? Okay, thank you, Lakshmi. Thank you, Dheeraj. Okay, thank you, Padmanabhan. And but as DevOps engineer, do we deploy applications on Kubernetes cluster? Like you will be having it as part of your CI/CD workflow, Pawan. So having the knowledge of Kubernetes will definitely be helpful, because maybe in your current project you might not be using the Kubernetes cluster, but uh, in the overall project you will be deploying your application in the Kubernetes cluster. So like let me just give you a quick idea as how does the code would look like for example, this is an example deploy.yaml file where it will be created by the folks. It can be from the developer team or it can be from the administrator. They'll configure this file, and whenever they perform the commit to this repository, so we would expect that the automation should run, that is the CI/CD workflow should run over here for like a CI/CD workflow should run over here, so that the new code that is coming in, so it can be built and it is deployed on the Kubernetes cluster. I'll show you with an example of the GitHub actions as how it actually look like. I don't have the code running, but I can show you in the actions page. So if I go to the actions page of this GitHub, see, these are all the various GitHub actions workflow that I have ran, where any commit that has happened to my repository. So we are performing the uh, like build. So this is like you can think of it as an alternative to the build one that you are using, build testing, build test and deploy. So here I'm making use of the GitHub action where we are checking out, we are performing the build using the latest code that has been pushed to the repository. And once it is built, we would go ahead and push to the artifact registry. In this scenario, the artifact registry that is being pushed is the Google Container Registry. And once it is pushed to the Google Container Registry, we'll update our deploy.yaml file and deploy it on our Kubernetes cluster, which is running on the Google Kubernetes. So Kubernetes cluster is definitely part of any software development deployment project. So obviously it depends on the organization size and the kind of project, but this is the general pattern that we would observe. Okay, thank you, Pawan. And any other questions, team? Okay, thank you, Diksha. Okay, I'm glad, Diksha, that you're finding it helpful. Okay, so next question that I say here is K8 is part of MLOps? So here at the end, whether it is the machine learning application or the software application, Kubernetes is there for deployment. So whether it is the machine learning deployment application, like application which is powered by machine learning, or the general one, so Kubernetes can be used. I mean, as I mentioned few things during our learning journey, we have got the various abilities which we can control how to schedule pods or way to schedule the pods using the various concepts of Kubernetes and schedule it in a required worker node so that it can run the deep learning applications too. Okay, T. Now, apart from these, now if you're someone who's planning to uh, getting started in your certification journey, I think there are some resources that has been added over here on the link that I've shared earlier. So this is the link which I've shared earlier as well. Let me share it because I can see few learners have joined late. So I'm sharing the link again. You can access the resources. There are a few practice questions that has been added and few more to be added in future as well. And we would be adding it in future where you can refer to it at a later point. So if I take you to the page, so this is how your course page would look like when you log in. So there will be a PDF which you can access it, which basically has got the content that we have used today. And there is also some practice questions and the slides related to the pods and namespaces if you're someone who is getting started in your learning journey of certifying with Kubernetes certification administrator. I'll also share the GitHub link for the demonstration purpose, like for the reference purpose. So you can go ahead and access it at a later point from that link. So this is the repository where we have the code that has been discussed today is present. Okay, so team, uh, if you've got any other questions, please feel free to let me know. So, folks, so as I mentioned, this session was made possible from the team of Manifold AI Learning. So, Manifold AI Learning is a platform which excels in providing the self-paced learning courses on the various topics like data science, machine learning, deep learning. And the latest course which I can recommend for the learners of this session is Python programming for DevOps and MLOps engineer. This is a special course that is being prepared. So you can expect the first batch of videos to drop in by April 15th. So the price that you see on the site is the early access, which is a lowest price as of now. So once the video is getting started, you will see the increase in price. So you can expect the first batch of videos to drop on 15th of April, and you can see the various topics that is covered, which is in line for any DevOps or the MLOps engineer, where you'll be learning about the Python basics, the libraries for DevOps, and how to automate the workflows with Python using the Python script, how to manage the infrastructure using the Python, and how you can deploy and scale the machine learning models. And we'll also talk about the best practices and tips. So that's the overall learning journey that you get to have in this Python programming for DevOps and MLOps engineer. So go ahead and register yourself, and also you get to, since you will be part of the early release, you'll also have the ability to provide the feedback for the course creation as well, so that you can be part of the course creation and add the new content, and you get to ask the questions. Like you can join these sessions and you can also ask the questions which are specific to your course related journey in manifold AI learning. Okay, so I'll be here on call for another few more minutes to answer any of the queries that you might have. And thank you so much again, team, for joining in, for taking your time and joining in for this live session. So it was wonderful to interact with each and every one of you. Okay, so Pawan says, okay, let me check with the support team. I've got a support team right now. Give me a second, Pawan. So I've just forwarded your request to the support team. Can you uh, share your email ID? Okay, so that I can actually, so that I can look into it on priority. I'll share it with the support team since they are on call with me. Thank you, Josie, and thank you, Rajshekhar. Okay, sure, Pawan. I've forwarded the request beyond call. So I've forwarded the request to one of our support team who is on there on call. So Pawan, you can see that I can check that. I mean, I just got a response from the support team. So you are already registered for the course. So what you can do is, once you log in to the page, click on dashboard, and under the dashboard, select the active courses, and from there you'll be able to access the course that you have registered with Manifold AI Learning. So do try that once. That's the feedback that I've got. So if it's not helpful, just let me know. We'll take it. We'll take a look into it at that time. Okay, that's great, Pawan. Thank you. Okay. How about others? Any other questions, team? Okay, thank you so much, everyone. So you'll be getting the link on the sessions recording within 24 hours. The sessions recording will be uploaded to the same page where you can access the slide. So you'll be able to access the sessions recording over there. So thanks again for your time, everyone, and I hope to see you on the next time. Okay, take care, everyone. Thank you, Dheeraj. Thank you, Lakshmi. Thank you, Shashidhar. Thank you, Pratiksha. Thank you, Karthik. Okay, thank you, guys. Okay, I see someone has raised the hand. Let me check. So Pawan, I see that you have raised the hand. Please let me know if I've allowed you to speak in case if you want to speak. Yeah, please go ahead.